Okay, so this is the higher periodic table question. Okay, this question is about group 1 elements. So group 1, we know they are metals. I know they are very reactive. Okay, they have low density, they're not typical metals. So a sodium atom is represented as Na1123, so that means its mass number is 23, so there's 23 particles in the nucleus, and there are 11 electrons and also 11 protons. So let's box this then. So complete means we have to finish what's already there. The diagram below to show the electronic structure of a sodium atom. So what I'm looking at for here is 11. So I need to put 11 electrons on. So my first shell I always have 2, 1, 2. Next shell can hold 8. So 1, 2, 3, 4, 5, 6, 7, 8. So I've got 10 of my electrons on, and then the one on the outer shell. Okay, so it's in group 1, so I know there's got to be one on the outer shell. A teacher demonstrated the reaction between lithium and water. Okay, so lithium is group 1, so we know it's going to be very, very reactive. So the teacher repeated the demonstration using sodium and then potassium. So sodium is even more reactive, and then potassium will whiz around on the water with a lilac flame. So that's the most reactive of these three. The teacher wore eye protection. Suggests 2 other safety precautions. So we need to make sure we put 2. If we don't put 2, we don't get 2 marks. If we put more than 2, we don't get 2 marks. 2 other safety precautions the teacher should take. So suggest means what I do is I need to use my knowledge for this situation. I need to use my knowledge of group 1 elements and also safety. So the first thing is they need to use tongs when handling the metals, because the metals will react with the moisture in your skin, and nobody wants that. So use tongs when handling the metals. The second thing is that they need to make sure that there is a screen between the teacher and the pupils, okay? Because sometimes when the metals are whizzing around, they can hit the water and the glass at an angle, and they can jump out. So you need to make sure there's a screen there. So make sure there is a screen between the metals reacting and the pupils. Okay, next bit then. Universal indicator. Okay, so that universal indicator is what we give. It shows the full pH scale. So all the different colours from pH 1 all the way to pH 14. So it gives us it's a mixture of different indicators, so it gives us all those different colours. So it's added to the solution formed in the reaction between potassium and water. The universal indicator becomes purple in colour. So if it's purple, okay, then it means we've got a pH 14, so that is a strong alkali. So which ion, so which just means we need to pick, which ion causes universal indicator to turn purple? So if it is an alkali, then alkalis are hydroxides. Okay, so the one of this, which is a hydroxide, is this one. So this is your hydroxide ion. That is what gives alkalis their properties. D, the table below gives the diameter of the atoms of group 1 elements. Okay, so let's have a look. So what we've got here is we're going down the group. So lithium, then sodium, potassium, rubidium, cesium. So we're going down the group there. So as we go down the group, if we look at the diameters, they are getting bigger. So we've got an increase in diameter. And because I know for group 1 elements, they are least reactive at the top and most reactive at the bottom, okay, so the reactivity increases. So when group 1 elements react, what they're doing is they are losing their outer electron, and the outer electron is held in place by the positive pull of the nucleus. So if we look at lithium at the top, we've got the positive nucleus, okay, and then we have our outer electron. By the time that we get down here to cesium, not only do we have a bigger distance between the positive nucleus and the outer electron, but also we have lots more shells in the way, okay? So I'm being asked here to explain, which means I've got to link ideas. So I've got to link this idea of diameter, okay, to reactivity. So explain how the diameter of the atom affects the reactivity of group 1 elements. So first of all, I'm going to say what I see. So as the diameter of the elements increases, the reactivity also increases. Okay, so what I now need to do is I need to make it an explanation. So this is because when group 1 metals react, they lose their outer electron. Okay. The electrons that are further from the nucleus are lost more easily because the attraction the nucleus is weaker due to increased distance and shielding from the different shells.